Dear students, today you will be learning the working principle of three-phase induction motor and its working. First, we will take the working principle of three-phase induction motor. Three-phase induction motor works on the principle of Faraday's law of electromagnetic induction. That is, an EMF gets induced in a conductor if flux linking with it changes. Also, on the principle a conductor carrying current placed in the magnetic field experiences a force suggested by French scientist Andre Marie ampere, who lived between 1775 and 1836. Now we will take working of three-phase induction motor. In last class, we have studied that when a three-phase balanced winding is supplied with three-phase balanced voltage, a rotating magnetic field is produced. The magnitude of this rotating magnetic field is constant and it rotates at a speed called synchronous speed. To understand the working of three-phase induction motor, let us consider a stator in which a balanced three-phase winding is placed. Here we will consider very simple stator in which three windings are placed at 120 degree apart from each other. No slots are shown. The three-phase winding here may be connected in star or in delta as per the requirement. So these are the three-phase windings here. To this winding, if we supply three-phase balanced voltage, then a rotating magnetic field is produced. This rotating magnetic field cuts the rotor conductors which are placed on rotor core inside the stator. Now we will show here the rotating magnetic field as an arrow with its axis of rotation coinciding with the axis of stator. Next, we will show the squirrel cage rotor placed inside the stator with the conductors. We will name here the different parts. First one is the stator winding. It is placed in stator core. Here is stator core. Between stator core and rotor core, there will be the air gap to avoid friction, so that air gap we will show now. Next, N rings used for short circuiting the rotor bars or rotor conductors. The small circles here are rotor bars or rotor conductors. Inside circle is a rotor core. Let us assume that the rotating magnetic field rotates in clockwise direction and keeps cutting the conductors one by one. It may be shown with the help of pencil like this, rotating in clockwise direction. When the rotating magnetic field cuts the conductors on the rotor, an EMF gets induced in them. According to the Fleming's right-hand rule, the direction of EMF in this conductor is into the paper and may be shown with the help of a cross mark. To find the direction of EMF by Fleming's right-hand rule, we must know the direction of magnetic field is upward and it is rotating in anti-clockwise direction. The direction of relative motion of rotor conductor with respect to rotating magnetic field is anti-clockwise, and it may be shown with the help of an arrow. Since all the rotor conductors are short-circuited with the help of N rings, the current flows through the rotor conductors now, and the situation is a current carrying conductor placed in the magnetic field. Now, the rotor conductors will therefore experience a force. The direction of this force may be found by using Fleming's left-hand rule, and that is clockwise. We'll mark area F. Since this force is acting on all the conductors on the rotor in the clockwise direction, the rotor as a whole rotates in clockwise direction. The speed at which the rotor rotates is called as the shaft speed or the rotor speed. The rotor speed is always less than the speed of rotating magnetic field, that is synchronous speed, because if the rotor speed becomes equal to synchronous speed, then the relative speed between conductor and magnetic field becomes equal to 0 and an EMF will not be induced in rotor conductors. Hence, there will be no current flow and there will be no force acting on the rotor conductors. Hence, the motor will not operate. Now we will summarize the working of induction motor, which we discussed above. First, three-phase balanced voltage is applied to balanced three-phase winding of stator. At start, rotor conductors at rest due to relative motion between magnetic field and rotor conductors an EMF is induced in rotor conductors. Rotor conductors are short-circuited through end rings or slip ring and carbon brush arrangement. As the case may be. That means it depends on type of rotor. So, current flows through them. Now situation is a current carrying conductor placed in magnetic field. So these rotor conductors experience force since rotor conductors on the rotor core, rotor as a whole starts to rotate. As we discussed at the as we discussed, if rotor conductors start to rotate at the speed of rotating magnetic field, then torque produced is zero. The rotor conductors or the rotor as a whole will always be rotating at a speed lesser than synchronous speed. So we'll write that. The rotor rotates at a speed lesser than synchronous speed. The speed at which rotor rotates is called shaft speed or mechanical speed. Mechanical speed is denoted by Nm.